Hello, ladies and gentlemen. Welcome back. Root Beer here with more of the 2015 Cimc. That's the intermediate paper aimed at grade levels 9 and 10. We're on to question number 2. Question 2, it says, in the diagram, ABCD is a square with side length 4. They don't have that labeled in their diagram. That's okay. When we draw ours, we'll add that in. Points P, Q, R, and S are the midpoints of the sides. Okay? And we've noted that on the square shown because we have these lines running through segment PB and AP. And the fact that each line runs through here means that each of these lengths, so SD, BQ, RC, all of these must be equal. So they split each side in half, and they split all the sides in half. So we're asked, what is the area of the shaded region? Okay, these questions, this style of question comes up every once in a while. So what's the area of the shaded region? We're given certain information. Let's draw ourselves our own picture. Okay, and that way we can mark it up and add in whatever values or other points we would like. That is an awful square, and I apologize to everyone. Let's see if we can do a little better. That's a little better. A, B, C, D. I'm pretty sure S went here. That's probably P, Q, and this should be R. So we connected these two up. So PQ and R, S, and we want this region in here. Now, oftentimes, when it comes to find the area of the shaded region question, there's two approaches. And one might work sometimes, one might work other times. Sometimes they might both work and you get to choose. It's wonderful. So one of the methods is take your shaded region, which is oftentimes a very weird shape, as in the case with this one. It's a sort of a weird, flattened, rotated hexagon, and break it up into smaller shapes that you recognize and can compute the areas of. Add each of those areas up, you're done. The other way is to sort of encase your or surround your shaded region with a shape that you know, in this case a square, and arrive at your shaded region by cutting out other shapes that you know the areas of. So actually both methods will work in this particular case. So I'll show you how to chop it up using the blue. What we could do is we got right angles here. So what we could do is connect up SP and RQ. This in here is going to be a square. And each of these are right angle triangles. And we'll know the base is 1 and the height is 1. So these are triangles. So we figure out the area of each of these two triangles and the area of the square, and we'll be able to work it out. And you can do that for all of this. The other way to do it, which we'll illustrate in red, just put a little picture down here, start with the whole square ABCD and chop off these two triangles. So in this case, the shaded region is equal to the square minus the upper corner, or minus the lower corner. Okay. And if we do that, and we know that the side lengths here, oh, sorry, these side lengths shouldn't be 1, they should be 2, because the question tells us the side length for ABCD is 4. So splitting them in half, we get 2s, not 1s. So each of these is 2. And the area should be 1/2 base times height. Well, this 2 is the base, and this 2 is the height. This 2 is the base, this 2 is the height. So the area of the square is the side length squared, and then minus one triangle, which is half base times height, minus the other triangle, which is a half base times height. So we're left with 16 minus 1/2 times 4, minus 1/2 times 4. So 16 minus 2, or 16 minus 4, which gives us a final answer of 12. Okay, so that's the chop things off in order to get to your shaded region method. If we'd done it with trying to compose it with these two smaller triangles in the square, each of these triangles will be size 2, area 2. So 2 plus 2, and then this square in here will have side length 2 root 2. So it'll have an area of 2 root 2 squared, which is 8. 8 plus 2 is also 12. So there, I've verbally done it the blue way, but in this case, I prefer to do it the red shaded way. It saves me from having to figure out the length of hypotenuse RS. So it's just a little quicker. Not that much of an issue. Either method will work. It's question 2 on part A. These ones shouldn't be hard for you yet. Okay? If they are hard for you, then I would recommend actually going back and taking a look at some of my other videos, like the grade 7 and 8 Gauss papers, the grade 9 Pascal paper. These ones are aimed at a little lower in terms of a little earlier in terms of the education. So they're aimed at grade 7s and 8s and the simpler grade 9 questions. So you can try those, work your way up, build up your problem-solving skills, and then come back to these questions. So that's question 2, and we'll take a look at question 3 in the next video, and I'll see you guys then. So long.